All right, people, we are going to start our new topic and our last topic. All right. Sure. All right. So our last topic is integration. So it's going to start off pretty easy. The stuff we're going to do today is not hard at all. It gets a bit harder later. So we are going to look at what integration is, which is the opposite of differentiation. So you already know how to differentiate. So if I said, why did I write the X on the top? If I gave you the derivative, right? So let's say I give you a function that is 4x cubed minus 6x squared plus 10x minus 10. You should, given your knowledge of derivatives, be able to work backwards and actually give me the function of x, or y equals. Tell me what you think we're doing. Work backwards. What does my first term have to be? Okay, it's x to the power of 4. What's the next one? Minus 2x what? Cubed. 5x squared minus 10x. Good. Okay, so what? What do you mean? Yeah, we're about to get to that. So that is the problem. John has exactly noticed so if I gave you this, we've been going to that. But when we work backwards, the problem is if there was something over here, it's gone up here. What on earth was it? Maybe it was nothing. Maybe there wasn't a constant. But if there was, it's going to disappear. So what we're going to do when we write this is call it plus C. C for constant, right? We don't know. There could be something there. There might not be. There usually is, but we always need to write plus C when we're doing our integrals, right? So when we're reversing the process, we don't know what it used to be. So what I'm going to do is show you, because this was pretty easy, but I'm just going to show you some slightly different notation. So what I can do is I'm going to take my derivative, right? I'm going to call it 4x cubed, sorry, 4x to the 4, right? I'm going to increase the power by 1, and then I'm going to divide by that power. That's what I'm going to do here as well. I'm going to leave it at 2. Sorry, I'm going to leave it at 6. So I've got 6x. I'm going to increase that power by 1 and divide by the new power. Same here. I've got 10x. I'm going to increase the power by 1, divide by the new power. Same here. I'm going to increase, whoops, I've just done that, haven't I? Oh, sorry, I'm up here. I'm going to increase the power by 1, divide by the new power. And then I need a C on the end. So you could do that in your head before, but if there's weird fractions and stuff, it's not as easy just to straight do in your head. So you'll see here that as we simplify this, 4 divide 4 is just 1. So we get this term. 6 divide 3, this is a minus, is 2. So we get this term. Same with this. 10 divide 2 is 5, which gives us this term. Dividing by 1 is just itself, and then we've got the C. So this is how you do it if it's not just easy whole numbers. All right, so let's look at another example here. Right, I'm going to get you to try this. I'm going to give you, can you grab out your pen and paper for me? Whoops, did not mean to get rid of that. All right, I'm going to give you the derivative dy dx, and I'm going to ask you to give me the original function. Right, please give me the original function. So you're reversing the process. All right. Looks like most of us are done. All right. So I'm going to increase the power by 1. I'm going to show you how to do it the long way. If you skip straight to the end, that's fine. But we increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Don't forget your plus c on the end. So that should mean that you got 2x to the power of 5 minus 3x cubed plus 4x squared plus 10x plus c. We all got that? Excellent. Right, what I'm now going to introduce to you is the notation of how we write integrals. So this is what you're being asked to do, but it's going to look different. They're not going to say, find the integral of very often. What they're going to do is just give you the notation and you're expected to understand what they're asking. So in a very similar way, if I am going to give you, let's say that I'm giving you 5x squared and I want you to find the integral. They're going to put like this long S sort of thing, right? This is the symbol for integration. So they're asking for the integral of this, and then you always put dx on the end, because what they're asking for this is they want the integral of this with respect to x. Now, if you wrote 5m squared, this would be dm. Right? So this letter is just whatever letter is that you're using. It's usually X. Sometimes it's T for time. That's the more common one, but they could use even Y's. Okay, so just whatever letter they're using, that's the letter you use. So for something like this, this would be relatively simple. What is the integral of this? You should be able to do that just one term. What is it? Good. 5/3 x cubed. You could write it like this. It really makes no difference at all. Both of these are right. And then did I hear someone say something I should have done? Plus c, right? I always need to write my plus c. Now, this is fine. If you've just got one term, you can write it like that. But if you have multiple terms, if they're asking for the derivative of, let's say, 3x cubed plus 2x squared minus 4, this must be in brackets because it's more than one term with respect to x. Okay, so if you see brackets, all it means is you want to derive this whole thing here. If there's no brackets, it's because it's a single term. Can you derive this for me, please? This time you are going to end up with fractional answers. All right, so derive this for me. Very difficult. All right, so you should have ended up with some weird fractions for this one. You should have ended up with 3x to the power of 4 over 4 plus 2x cubed over 3 minus 4x plus c. Did we end up with that? Good. All right, let me give you one that's harder. All right, so we're going to end up with some weirder things this time. Let's... Right, please find me this integral. So you're looking for the integral of this function. There are two different ways you could do this. As long as you get the right answer, I don't mind which method you use. What did I say before? No, the derivative. I'm giving you the derivative. Sorry, I meant to say find the integral. My bad. So this is the derivative. Find the integral. So there are two ways you can do this. I'm going to do it both ways to show you that you get the same answer either way. 1 over 2. That's a square root.
Times x times -1.
Not times to the
Oh,
power.
x.
Yeah, right. Yep. So you can certainly do it like that, right? This is the same thing. I have done my division, right? I've divided both terms by x. So I shouldn't have written that. So then my derivative is going to be 2x plus 5x cubed over 3 plus c. If you wanted to rewrite it, so that you've got x to the -1 times 2x plus 5x cubed, you could have done it like that with respect to dx. So if I'm going to do that, what I'm going to do is put this on there. So then I'm going to have, I'm adding my power. So this is -1 plus 1. So that just gives me 2. And then I've got 3 plus -1. So that gives me squared. See how I get the same thing either way? Doesn't matter which way you think of it. And then again, you do your integral. You should get the same answer either way. Yeah? So bring it up, add your powers together, or do your division like that. Same thing. It doesn't make a difference.